When adding and subtracting fractions, the denominators must be the same. If they are not the same, then we need to write equivalent fractions that have the same denominators. This new denominator is called the least common denominator, or the LCD. When we are looking for the LCD, we're really looking for the least common multiple of the denominators of the fractions. So if I look at 3/10 and 4/15, I want to find the least common multiple for 10 and 15. We have two methods for doing this. The first method has us list the multiples of each denominator. Then we will look for the smallest multiple, or the smallest number, that those two lists have in common. I've listed the multiples of 10 and the multiples of 15. We can see that the smallest number that these both have in common is the number 30. So therefore, my least common denominator for 10 and 15 would be 30. Now this method works great for any set of fractions that we have. However, it can be a little bit time-consuming to have to list out all of the factors and then look for the smallest one. So we have a more efficient technique. So our second method is prime factorization. For prime factorization, we're going to find the prime factorization of each denominator. Then we'll look for any common factors that they have. And then we'll multiply the factors of our numbers, taking common factors only one time. Let's look at an example to see what this means. So if I take 10 and break it down into its prime parts, it's 2 times 5. And 15 into its prime parts is 3 times 5. So if I go ahead and list those, I can now see that they both have a common factor of 5. I want to take that common factor only one time and multiply it by the remaining factors there. So my LCD is going to be 2 times 3 times 5, multiplying to get 30. Notice I get the same answer as method 1, just a more efficient technique than method 1. You can use either method to find your LCD. We're going to practice with a few more examples. I'm only going to demonstrate method 2 in these. However, we could obviously use method 1 as well. So for example A, I want to find the LCD, or the least common multiple, of 6 and 20. So I'm going to start by finding the prime factorization of 6, which is 2 times 3. And then I'm going to find the prime factorization of 20. Now 20 breaks down as 10 times 2, but 10 is not prime, so I'll break it down as 2 times 5. Listing its prime factorization, 20, is 2 times 2 times 5. Notice that the two sets of prime factors have a common factor of 2. So when I find my LCD, I only use that value once. So my LCD is 2 times the remaining factors of 3, 2, and 5. Multiplying them together, I find out my least common denominator for 6 and 20 is 60. Let's practice with one more, and then I think you'll be ready to try a few on your own. So again, I want to find my LCD for 8 and 12. So I'm going to start by finding the prime factorization for 8 and 12. As I go through, 8 will break down into 2 times 4, and then 4 can be broken down as 2 times 2. So my prime factorization of 8 is 2 times 2 times 2. Repeating the process for 12, 12 breaks down as 2 times 6, and then 6 will break down again into prime parts as 2 and 3. So 12's prime factorization is 2 times 2 times 3. This time, notice that my sets of prime factors have two common sets of factors. They both have 2 2's. So my LCD, I'm going to take only one 2 from each group, and then multiply by the remaining 2 and 3. Multiplying those numbers together, my LCD for 8 and 12 is 24. I think you're ready to try a few examples on your own now. For the set of problems, you can use either method 1 or method 2, whichever you want. So go ahead and pause the video. When you have finished, you can resume watching the video so that you can check your answers. Good luck! I see you've decided to come back to check your answers. Great! I've provided the answers using both method 1 and method 2. Go ahead and check your answers. If you've got the answers correct, then I think you're ready to go ahead and try adding or subtracting fractions.